Hello, and thanks for joining me at IT Homelab Online. In this video, we're going to build a dedicated Llama stack in Docker, wire it up with its own Tailscale sidecar, and be ready and available for you to connect your other services to it without rebuilding the whole thing. By the end of this video, you'll have Llama running in its own isolated stack, and it will be completely accessible over Tailscale. This is running on my Docker 01 Ubuntu VM, which lives on my Dell Latitude 5411 Proxmox host. Before we get into the stack itself, I'm going to be bumping the memory on the VM from 4 gig to 12 gig, since Llama needs some breathing room to load models into memory. Now, let's get started. First, let's sort out the memory increase. So, shut down your Docker container, and we go into Proxmox here. We're going to go into the Docker container here. We're going to go to hardware and increase the memory here. This is one I built in a previous video, so if you want to check that out, you can. There'll be a link below. And that's all there is to it. So now I can start that up. Open the console just to check the progress. Okay, and that's booted. So just minimize that for now, and we'll SSH into that Docker container. Okay. Now I've already created my compose file, so I'll jump into the folder that has it, and I'll make this available on the GitHub for you. Feel free to edit, distribute, whatever you like. So it's in the media Docker scripts folder, and then I've created a new folder called Llama, just to keep this as a separate stack on its own. And I'll go through the compose file so you can see what's contained in there. Okay, so you can see here it's pulling the official Llama image, and it'll get the latest version. It'll only restart if, it will restart every time unless you specifically tell it to stop. This is a label to tell it to automatically update using Watchtower. Now, there's a few things I've added in here just to basically make it more connectable. So you need to have the Llama host in there as everyone. Otherwise, you can only access it from within the Docker container. You can't connect any of your Hermes agent or OpenClaw or anything like that to it without having it open to other devices. This is just to keep alive, to keep it up and running. This is to basically reduce the amount of processes that it tries to run at the same time. I'm just running on a standard GPU laptop, so CPU laptop, doesn't have a GPU. So I'm trying to keep the workload down on it. And same thing here, because I've got limited memory, I'm only allowing it to load one model at a time, or one or two models at a time. That keeps that down. And that just limits the context length to 8 meg. So down here, this is my standard setup. All of my configuration files are stored in a variable. I'll show you that in a moment. So it basically points all the config to the one location, which means that it's easy to back up this one folder to back up your entire Llama, or if you need to go lift and shift, you just move that folder with it. This is pointing to its own Tailscale network on the side here, and it depends on that work being up and running. Now I've put just some commented out section in here that refers to connecting it to video drivers if you have an NVIDIA card. As I said, I don't, so this functionality won't work on my setup, but if you had the NVIDIA, you can just remove those comments and away you go. Looking at the Tailscale sidecar, you would have seen this format from me before. I have my Tailscale auth key in an environment variable, so you can see there. It'll give it the name Ollama, so it'll be Llama dot tail-scale.ts.net when you set yours up, whatever your Tailscale network is. And they're just pretty much standard settings. That's the default port that Llama uses, so we're not going to mess around with that, and we'll leave that as it is. And it's set up on its own unique bridge network. Okay, I'll quickly jump out of there and show you the environment variables. I have two sets of environment variables. This is the one that most of you will have. This contains all of the environment variables, so my time zone, my user ID, and my configuration folder. I've got a dummy TS auth key in there. This is hung over from the previous video that I did where I installed Vault Warden, so you can have your own Bitwarden instance server. And these are the variables that I mentioned earlier that within the compose file. I'll also just show you, I also use a secrets file that I have the true Tailscale auth key. I obviously don't want to expose that to the world. And the same with my Vault Warden admin key. So I'll just quickly show you those. So you can see there that that file exists there, and it's got some data in it. Okay, so the next thing I'll do is I'll bring up this this Ollama container. Now I have set up an alias, and I'll quickly show you what that looks like. Um, so this is my alias file, and basically what it has is Docker up, which runs the Docker compose command, and it uses my two environment variable files. So there's the .env there, and there's the secret one that I mentioned to you earlier. Post those into my bash rc, which is effectively setting up my environment. So now what I can do is I can do a docker -up, and that will run this this command here. So it'll say docker compose environment files up -d, which is disconnect. So I'll run that. Yours will take a little bit longer the first time because it will pull down the Llama containers. Mine's already pulled it down. And now if I go into Tailscale with a bit of luck, I should have an instance in here for Ollama. Just do a refresh. Okay, so now we can see our machine count's gone up. And there we have Ollama. So what I'll do is I will disable the expiry key just to make it long term. So now we should be able to go back to our container. Now from here, we should be able to pull an LLM model. So we want to do that within the container. So I'll do a docker exec Ollama, and then I'm going to do a pull and select a model. So I'll do Ollama 3.2, designed specifically for this. Sorry, Llama, not Ollama. Okay. So my container name is Ollama. My executable is also Ollama. So if you want to avoid confusion, you could rename your container as my Ollama or something like that. So I'm doing a docker exec of the Ollama container to run the Ollama pull llama 3.2 command. Say that 3 times quickly if you can. And you can see there it's pulling the manifest. Okay, so now that that's downloaded, what we should be able to do is we can send it a command. So from Docker, Again, Docker exec, my Llama container, and then I'm going to say Ollama, run, the name of the model that we just pulled down, so Llama 3.2, and then I'm going to say hello and give me a 2-line explanation of who you are. And there you go. So it's given a quick explanation. Now, obviously, you don't necessarily want to run it through the Docker exec command every time. What you can do is you can do a Docker exec Llama bash. That didn't work. Ah, let's try. That gives us an interactive prompt. So now we can do, say, a llama. We'll just run a llama actually. Then we can select chat. We can choose our model. The llama one hasn't shown up in here. So these ones require a sign in. So I'll quickly do the Qwen 3.6. No, this one's smaller. I'll let it download. Just while that's downloading, I'll go in and confirm that that the Tailscale is working. I'll go into here, copy the URL, open a new tab, and put in the port number. And then you can see Llama is running. So what you would do is with your Hermes agent or Claude Code, whatever you're using to point it to your Docker, you'd simply use that address, which is your Tailscale address with port 11434. Okay, so now we're into a chat window. So now we can ask questions here directly. Um, so what model are you running? Now this model's obviously a larger model than the Llama 3.2 that we installed, so it'll take a little bit longer to respond. So there you go, it's responding, and that obviously corresponds with the model number listed below there. So that's it. Now you've got Llama running in its own dedicated resource tuned stack with a secure remote access via Tailscale, and you can connect it to any of your other agents or services. Splitting it out like this means that you can scale its resources independently, and you can also isolate its logs and that sort of thing. So it's a lot easier for troubleshooting. And it also means that if you're in a home lab environment, you can easily transfer from one set of hardware to another to help scale it as well. So if you found this video helpful, please like, subscribe, and hit the notification bell. Thanks for watching, and I'll see you in the next one.